Next up is the Cut Solid by Curves tool, and it's quite badly named really because it doesn't have to be a curve that you use as a cutting element. It can be almost any shape in fact. Let me show you how this works, but first we need to look at the tool settings window. We have a cut direction and we have a choice of both forward or back. Now forward or back requires you to follow the right hand rule, and it relates to the direction in which the profile was originally drawn. If a profile was drawn clockwise, you will cut forward into the screen like a corkscrew, or if the profile was drawn counterclockwise, then you will cut out of the screen. However, the chances of you knowing which way it was drawn is quite small, and in my case, I never know. So do what I do and use trial and error. I always find that works well, which is why they invented the Control-Z key. So I'm using both at this point, and you'll see how that works. Second is the cut mode, and that can be either through, which means it goes entirely through the element, or you can define a specific depth. I'm leaving through on at the moment. Here's the cut depth value, which will become active if you select define depth. You can do what's called split the solid, and with this option on, the solid is simply split and both portions remain in place. With this option off, as it is now, the solid is cut and one portion is removed. The identifying data points on the solid also select the portion that remains. And of course, keep profile is the standard keep or discard the profile. So let me show you how this works. And this, by the way, is one of my favorite tools. I'm going to draw some construction lines first. And I'm going to use the line tool. I'm going to use my center snap and snap to the centroid of this cylinder. Need to change the orientation and just pop a line up there. At the same time, I'm going to draw a line in this direction. Somewhere about there will do. And now I'm going to place a couple of circular profiles on the top of these things. So let's change that to top view and plop a circle there. We'll do the same with this. Change that and put the same size circle there. Now we start the tool. So I'm cutting both directions. I'm cutting through. I'm going to select the solid first, then the profile. I'll select that one. And note that the directional arrows are both up and down, meaning it will cut in both directions. And our data point. And that's what I see. Let's shade that. And we see that I've drilled a hole right through this solid. Back we go again. So let's start the tool again. I'll select the cylinder and the profile, and now we're running in that direction and there. And let's do a shade. And I've drilled two holes through this cylinder, and you'll see that they are both completely through the cylinder. And again, this is why this is one of my favorite tools. Let's try something else. Let's work on this cylinder. I'm going to place another circular profile. Need to change orientations. Going to drag about there. So that's my profile. Going to use the same tool again. So this time I need to change a couple of settings. Both is going to be on because I have no idea which way around this is drawn. I need to define the depth this time. I don't want to cut this cylinder through its entire depth. That automatically turns on cut depth, and I've set it at 6 already. So now I select the cylinder and select the profile. It wants to cut in both directions. That's fine. And data point, and there we are. Let's have a look at this thing. So I'll shade it. Now I see a red end on here, and that's simply because when I used the tool, I kept the profile on, which was a little silly, but we can solve that easily. I'll simply go and select the profile and delete it. And now, when I do a rotate, we have a blind hole rather than a hole which runs right through the cylinder. So that's a very nice way of doing things. Let's get that back to isometric. Now, so far so good with that. I've drilled a nice blind hole, but it's just a regular hole. What if, for example, I needed a countersunk hole with a conical bottom, which you would normally use for a tapped and screwed hole for a screw? How would I do this? Because this tool with a single circular profile won't let me do that. Well, there are a couple of possibilities. One answer is to construct a separate solid of the hole, the countersink, and the cone, then insert that into the cylinder in the same location that I just placed the circular profile, and then use the subtract solids Boolean tool to achieve that countersunken board hole. Another way, which will help a little bit, is to chamfer the edges that we have here, and we'll look at that actually very shortly. So there are some ways of achieving the same results in a different way. Let's move on a little bit to a slab, and I'm going to put that into wireframe. So the line I need is a smart line, but I don't want to do it in isometric view. It will cause complications. So what I'm going to do is tile everything, and I'm going to go to my front view. And here is my slab in front view. There's my slab, there's my front view. So I'm going to start from this corner and draw myself a sawtooth pattern here. Now I'm doing it this way because I know that my line is in the plane of that front face of the slab. Now I'm going to use the tool. I've got through and both set, no depth. And I'm going to select the solid first and then the line. And what I expect to see is that the line will cut right through the slab. However, it doesn't. And the reason is that under these conditions, the line must extend to the edge. Now what I can do is use my line extend, and rather than just go to the edge, I'll go right the way through. Let's change that to V. There we go. So I've just extended the line right the way through. Now let's try my tool. Select the slab, select the line, data point, and this is what we get. Let's zoom back into full isometric. And there we see that the line has provided the cutting line for the slab. This is what I mean about the name of this tool, Cut Solid by Curves. You can use any shape you wish. Keep in mind too that it doesn't have to be a line. So circles, arcs, practice please. Extremely useful tool. And let me suggest something. You are aware of the angle bracket with the web that you've been drawing 3 times up to this point. But try it with this tool. And the procedure is simply to extrude the full L-shape angle of the bracket itself, and then chop off the corners with this tool and add the web. You could also, if you wanted, start with a complete full-sized slab of the entire shape. In other words, a rectangular slab. And then take off the bits and pieces that you need with this tool. That works too. That's a long way around. Try it first with the extrusion, chop the corners off, and add the web. You'll find it's very, very quick. And while we're at it, here are a couple more shapes that you can use for this tool. Now, just use a 1 grid unit to draw these 2 shapes with. So everything's in multiples of 1 grid point. That will make life quite quick for you. It would be nice if you did, because we're going to use these very shortly for the next tool.